Hi, folks. I just wanted to run through that ladder problem that I showed you yesterday. This is the one that I had drawn on the board. I have this set up with my ladder at a 75-degree angle, and it's resting on the ground. The base here is going to be the fulcrum. That means that the rotation is going to occur around that site. It's 6 meters long. The ladder is resting against the house, and the house is pushing directly out with a normal force, right? Like responding to the pressure that the ladder is putting against it. Because the horizontal forces here have to be in balance, the normal force of the wall has to be equaled by the force of static friction at ground level. Now, the ladder itself is going to try and create, in this case, a counterclockwise torque because the force of gravity is going to be pulling straight down. And the person on the ladder is going to be creating a counterclockwise torque, pulling straight down. But we only use the component of the force that is perpendicular to the radius. So in this case, I've identified that this angle in here is 75, which means this is mg cos 75, this component right here. And this is mg cos 75. We also know this angle is 75 degrees, which means that the portion of the normal force that is acting at right angles to the radius is Fn sine 75, because it's not touching the angle. So sine 75 here. So because this situation, or because this scenario is in static equilibrium, there is no rotation taking place, we know that the torque, the clockwise torque, and the counterclockwise torque have to be equal to each other. The wall is generating the clockwise torque. Force in the perpendicular direction to the radius multiplied by the radius, how far away that force is being applied from the fulcrum, that's going to be your clockwise torque. Here we have the mg of the ladder. The force is mg. You have to multiply by the cos 75 to turn it into the component that is perpendicular to the radius, multiply by the distance that the center of mass is away from the fulcrum. In this case, it's 3 meters, because that's the midpoint of the ladder. And then you have the person who is 4 meters away from the fulcrum, mg cos 75 again. And so we allow all this stuff to be equal. We know everything here except the normal force. I could give you a problem where the like the ladder mass is missing, or the person's distance away is missing, or whatever, but you would only have one unknown. But this is the way that the equation would be set up, and then you could just plug in all the values that you know and solve for the unknown. When I find the normal force of the wall pushing out, I also know the static force at ground level. And as you ascend the ladder, as you get higher and higher and higher, the torque generated by the person increases, which causes the normal force to increase, which causes the force of static friction at ground level to increase. And eventually, you could exceed the maximum force of static friction at ground level and end up with the ladder slipping. So this is that's a safety concern.